All right. Hello, everyone. I hope you can hear the music this time. I'm super excited to do this. Today, I think it will be quite special. So, yeah, we're gonna take a couple more minutes. Hopefully, few people will join. If you drop in, say hello in the chat. Say hopefully where you're watching from, and yeah, we'll get started soon. All right. All right. So I guess we can get started. Uh, I'm trying to get us a bit more time here. Hopefully, a few more people will join. Today, guys, I worked a bit on my setup, so hopefully it shows. We've got that blue light spread there. Had to go to 2 or 3 stores till I find exactly what I need without spending ridiculous amount of money. But yeah, I was happy. I was able to find it. I got a curtains as well, so that was good. I love the sun, and I would take the sun any day over snow. And as much as it's amazing, I do think that during the camera, the natural light is awesome, but then all of a sudden it goes from super amazing to a light drop all of a sudden. And yeah, it just messes up the lighting a bit. So yeah, exciting stuff. All right, let's see. Okay, so if you joined last time, you know that we probably, well, if you joined last time, we've talked about a bit of GraphQL, right? And we started with using GQL. Oh my god, I looked into the other video and I have not pronounced GQL correctly except once. I kept saying JQL. I think I was a bit more nervous with everything, so hopefully this time I'm getting it right. So yeah, we looked into GQL and we looked into a bit of the basics of GraphQL. But when I looked back, I felt like there's a bit of missing stuff that I could have done better in explaining with visuals. So I'm gonna start incorporating Figma into these things. And just to set up the goal, today I'm hoping to build something like a CMS backend for something like Notion. And I will address all the real challenges that could potentially be there. So things like optimistic concurrency and doing things like how are you going to handle updates without having to do extreme number of computations, right? Of course, we're not going to bend it in a day, right? And then also, when you look at something like Notion, there is amazing engineers working there, a big number of them. So there is no way we can just pull it off in one stream in a couple of hours. But what I can promise to do is that I'll try to do my best to explain everything that goes into my head into what a system like Notion might look like, and try to work together to actually get it up and running. Another thing that I wanted to say is I've been a bit reflecting about what kind of stream I'd like to do, and I think I'd like this to be a positive, like, how to articulate it. I want this to be a positive environment where we can try things, we can break things without like judging what we're doing, and only desire to like become masters in our craft. I also want to deter away from judging other people code. I've been really reflecting, and I do think in this community we tend to say like, oh, this is clean, this is not clean, this is disgusting, or we go around and like we make fun of different programmers or like different opinions. But realistically speaking, a lot of us are engineers, and a lot of us are trying to make it. A lot of us are self-learners too, and the fact that they took the time to get there is quite admirable. And I do believe we should have a round of applause for them, for everyone that is actually trying to level up. And that's exactly what we're doing here as well, right? No matter what our experience gaps are. So, exciting stuff. Okay, I'm gonna do a quick recap of what we spoke about last time, then we will get to it. Wonderful. So, last time we spoke about GraphQL. Actually, yeah, let's put it in the sequence. So we started off with like GoTooling, right? Here we talked about if you want to lock in a version of like the CLI, what are you gonna do? How you can handle that. And then we spoke a bit about GraphQL, where we discussed two things, right? We discussed what a mutation is, what a query is, and another thing is the distinction between GraphQL and REST. And I want to make sure that we have all of these locked in, because these were good foundations. So I'm gonna move a bit quickly, and if you have questions, mention it in the chat. And if the live stream ends and you're watching this later, drop it in the chat. I'll be more than happy to answer what I know. Great. So the Go tooling, we said that you have to create a package called tooling. This is the recommended approach. And once you do that, you just do go get, like as if you're installing any modules, and your Go mod file will be updated. So that is done. We discussed that. I think the video last stream actually was quite good into that topic, so that was good. All right, so here's what I want to focus on. The GraphQL, you've got the query, and what is a query? A query is something that you can use to get data, right? So let me just organize a bit so things are a bit cleaner, right? And I'm gonna put a rest in different color. Let's do a bit of a pinkish, right? So in REST, if you want to get some data, right? And I'm not talking about the appropriate REST, you have the concept of dividing things into resources. And that's why it's called REST, actually. If we look up the acronym, representational state transfer, right? So you do represent your entities or your resources as entities, and you're able to like query against them. So for example, if I do have a resource called books and I have another called authors, in REST, typically what you would do is you would go around and you would say like get all books, right? Or you can say like the API slash get book by ID, and you can do something along the lines of like ID equal 1 to XYZ, right? And this is the API call, or like what we think about as the URL, and this would return the book of that code or with that ID. And then when you look into the payload of that, it would typically include something like maybe author ID, which is going to be A123. It could include the title of the book. It include the ISBN, right? And a bit more information. So now, in order for you to get the author information, what would you typically do is you'd say, okay, give me that book by the ID. I have the ID now. I go make a network request, right? I think we can actually sketch this out. So get book by ID, and this would create a network request right to the server. Great. And now the server would say, okay, here's your result, which will become this data right here. And to make it crystal clear, here is your request. Let me zoom in a bit, just in case. Okay. Yeah. So here's your request. You go to the server, you get your response. And now you have to do another request to say, okay, now give me the author by ID. Which is in this case A123, right? This is coming from here, right there. And that's another request to the server, which gives you another response. Okay, so as you can see, like we did multiple going back and forth for just to return a book and an author. And if you can imagine, this can get a bit unwindy when you have a lot of data of different relationships and you're trying to get them back and forth. Okay, so what was the solution? Well, GraphQL. But before I explain the query and the mutation, the one last note I want to say. In REST, typically have an endpoint for the thing that you want to get back. And there's a lot of debates on the internet about how you organize that, how you establish a good RESTful API. Multiple books, so go check them out. It's important to learn how to organize these things, and do not organize them based on your function calls, because that's an older style that's like, it's not REST, it's not RPC, and it's something that's kind of like just in between. So just don't do that. So if you want to do REST, do it. It's still awesome. It still works. It's been powering the internet. So make sure you learn it properly. Great. Now, GraphQL doesn't actually have multiple endpoints. It have only one. So you could, let's stick with this example. In GraphQL, what you would typically do is like, you'd say like API / GraphQL. So this will be the endpoint that you send every request to, no matter what the request is. But the only difference is these are specifically a post request. Great. And actually, I'm gonna make everything extra large, so this way you guys can see. Maybe this is a large. Okay. So, and that's a main concept in GraphQL, because when you go to the server, when you create this request, it's actually having resolvers, right? Which are the things that are able to go to the database, or however you're organizing your data, and package them to you and send them back as a response. And the beauty of this, whenever you're doing a query, you can have nested. So your query could look something like, let's have something like this. Your query well, actually, it doesn't have to be a named query, right? But you can say, hey, I want a book with that ID. This is like pseudo GraphQL, right? But it's the same idea. So you do say, hey, I have a book with the ID that I want. On the return, also return the author for me, and the author, make sure you include their name, their most famous book, etc., etc., right? And here, of course, you can return the ISBN and everything else. Wonderful. Okay. So that's the concept of a query. That's the distinction between a query in GraphQL and a query in REST. So the post request, the nature of nesting, that you can just do one request and get him back. A mutation, typically in REST, you would use things like post or update, delete, the typical CRUD that we hear about. And there is few other verbs in REST. They call these verbs. So like get, post, update, put. These are all different verbs. And there's like semantics way to do it, right? There's appropriate way of doing it. In GraphQL, one endpoint, you've got your query, you've got your mutation. The mutation is anything that causes an update. So that could be things like, hey, delete this book, or update the title of this book. These are all called mutations because their purpose is to cause side effects or to cause change. Okay, so that's it for the revision of like what we spoke about last time. I just thought I could do a better job explaining it, and hopefully that was it. Again, join my stream, come in, interact, and let's grow up let's grow a community together. I think it would be super fun. Okay, now what? Now today, which is the main purpose of this stream, is I want to build a CMS system. The idea came a few months back. I was working on my own startup, and I actually wanted to create a way where authors and experts and domain experts to be able to publish content fairly easy in many ways. I really loved what TikTok did of like taking a video and pausing it and editing it. And I kind of wondered why a lot of like the blogging sites do not offer like a truly seamless experience. And there's a lot of like amazing tools out there. So if you look at like Wix is an extremely powerful site builder, but I've been using it for my blog, and honestly, it works, but it's not great. Like I do write my main content in Notion, and then it hit me. I was like, why can't we use Notion as our content management system, right? And I also decided that I'm like, okay, well, I don't want anyone to own my data, meaning that I didn't want Notion to be in control of what I put in there, because I want to establish search in my own way. I want to establish analytics if I want to. And at the time for the startup, I wanted to make sure that whoever wrote these things have full ownership of it. And because of that, I just didn't feel like delegating it to a third party with an integration, right? Even though Notion wouldn't be classified as a content management system in that case, there's other tools like Strapi and a bunch of others. I haven't personally used them. I looked into their documentation the past few days because I wanted to do something that's like cool without like reinventing the whole wheel. But if you're trying to get up and running quickly, definitely this is not the approach. I just think it's an interesting challenge, and I do believe that we will learn shit ton of stuff if we get it going. So let's get it going. Wonderful. What are the things that we need to consider when building something like Notion? Right. Well, what do we need to build in the first place? For me, what I'm trying to accomplish is I'm trying to have a clean interface that looks like Notion, where I can have documents in it, which will later become like blog posts, or could be an newsletter. It could be whatever, right? And I wanted to decouple this data from the content, but still have a way to describe it. My first solution was like, why don't you just store the content as pure HTML, send it to the database as a string or whatever. When you get it back, you can let your front end parse it, and off you go, right? I think that's a terrible idea, and for many reasons. One, imagine your front end asking, well, let me rephrase. Imagine your designer saying, you know what, we don't like the paragraphs to be looking like this anymore. We want to change the styling of it and do something like with the design. Well, now it's either you can write a really clever CSS to cater for these changes for all the rendered HTML, or that you'll have to go and change whatever tags have this class name or whatever. And it can get unwindy really quick because you're binding your data representation to how it will be viewed. So now your content is coupled with like the front end, right? Which is not what you intend to do in most cases. So you want to build a system that is composable and you can reuse it in multiple ways. If I want to put it on an iPhone, I can do that. My second thing was like, why don't we use MD? I mean, MD is great, right? Developers love MD at least. And with Markdown, I do think it's cool, but I think we can do better. I think we can do better. And the idea is, I don't want to teach people how to write Markdown on the front end. Right? If I have someone using my content management system, writing a blog post or creating an article, in these situations, I don't want them to write in Markdown. So you fall back into the hybrid solution where like they write into like regular HTML, or like they write into like regular text, and your front end is doing this work to translate between HTML to Markdown. Then you save it in the database as Markdown, that's a solution that is actually extremely viable, and I do think it's a good one. But I wanted to know what would be the challenges of building a different schema definition that would actually help us into creating this. And I think we can do better together today. So let's think. In Notion, there's this concept of documents, right? So we have something called documents. So let's start writing things down. Extra large. And let's use purple. Okay, so we have a document, right? And a document is essentially just a document. It's a blank document. So what makes the document? What's inside the document, right? Well, they do have blocks. So actually, let me go to Notion. And I'm not sure if my internet is slow or like my computer is being overwhelmed right now. So let's see. Okay, so here we have Notion, right? If I try to create a page, let's create a page. So we call pages documents in our model, okay? And it can have a title. So sample document. And here's the interesting thing that I want to focus on is like when you do like an H1, right? Sample, well, actually, let's just say H1, and you put some paragraph, text, okay, and then you have, let's say, an H2. Great. So here's your H2. You notice how are these like all different blocks, right? And what this allows you to do is that you can just move them around, reorganize them. So how would we implement something like that? And I'm not gonna focus on nesting right now. That's actually a pretty interesting challenge, and maybe depending on the feedback I get, we address it next stream. So let me know if you want to build like a full-fledged version with like nesting and everything. Let me know in the comments and we can address it. Okay, so now we have this concept of blocks. I want to call them segments. So we have segments. We have multiple segments. Okay, so here you go. Bam, bam, bam. Cool. So a document consists of multiple segments, and these segments you can reorganize them as much as you want. But these segments have rules on each of them, right? So for example, if this was an H1 segment, then it must be a title. So it must have a title. If this was a list, then it could have bullets, bullet points. I can't type anymore. And if this was a code segment, then we can say, well, I need to know what programming language, so language, and maybe, well, and the actual code itself. So, and here you might want to perform different type of stuff. So for the H1, you want to make sure maybe that the text do exist, and you don't want to incorporate it otherwise. You don't want to leave like a hanging H1, even though in Notion you can do that. Maybe in our solution we don't want to do that. In a code segment, we're using a highlighting service, and if we are, then it's extremely important to know the programming language, because you want to do proper text highlighting and you don't want like the red stuff everywhere. Sorry, be right back. All right. YouTube is telling me that I'm buffering, and that's what I'm trying to figure out, so you guys can have a smooth experience here. Let me refresh. Yeah, it is still complaining. I'm not really sure. Okay, I will just continue. And if it's still too bad for a while, then maybe next Wednesday. Okay, so we have a document, as we mentioned, and this document has multiple segments. These segments can have different rules on them. Now what? Okay, so now that we're able to create a document, what do we need to actually worry about? Because now you can just say, there's this plugin, actually it's pretty nice. Let me see if I have it here. Where did they take my plugins? Oh, wait, was it there? Oh, here. It should be here, yeah. It's called Code Blocks, and maybe we would be able to write code in here, but this is tiny. And if that's the case, yeah, no, fuck that then. Okay, we're just gonna do a text. Let's do extremely large. Really? Okay. So, what do we need to do? What do we need to worry about? First off, I want to say, how are we gonna maintain the order of the segments? How are we Okay, so that's for the segments. The second thing is, how are we gonna add different segments into the documents? Okay, also, how are we gonna maintain a huge number of segments in the document without like breaking our memory? think. Okay. No. Okay, so how are we maintaining the order of the segments? How to add different segments into the document? And how to maintain the segments in memory? As you can imagine, I could be writing a book, and a book an author might decide to do is like, you have this one huge document with just like the chapters and just like infinite scroll kind of thing. Or they could be a more reasonable and they could have a document with nested documents in them. So one of the segment actually could be a document segment, or in that case, a document. And you still need to maintain the reference for that. And I guarantee you that you don't want to maintain that object just like in memory, just living there. So how are we gonna do about doing that? And I want you to take a second to think. What structure might you use to model something like this, and why? How about just doing an array of segments, right? So if we have something like this, so I have my type document, which is a struct. You know what? Hopefully that is big enough. That's extremely uncomfortable. I got one of my most amazing friends today calling me, and he's like, hey, we could barely see your screen. And I'm like, we'll fix it. So hopefully this fixes it. I think actually I can go a bit more, to be honest. It's like massive now. Okay, so let's make a new directory for this amazing stream. And now let's make a directory for CMS backend. Go mod init. Actually I can do like stream projects slash CMS backend. Okay. In GoLang. Let's get going. Sorry, that was a bad joke. All bad. I have a bit of a confession to make. I've been trying to learn them. So yeah. That's the confession, so don't get scared if I just like pull out Vim all of a sudden. So yeah. And I'm not really sure if I should be doing this, but I'm so tempted right now. It's like to live learn Vim. So like I get a bit to practice while I'm explaining all these things. So maybe. I mean, it's right in the terminal. It's definitely way faster than this. I love GoLang, as I said. But yo, I do see the appeal for like an extremely fast editor to do whatever the hell you want it to do. Also, last time I had this sound effect and it wasn't working, and it was the most cringe thing to see without the effect. With the effect, at least it was a bit funny, but without the effect, it was like, god damn it, that was so awkward. Okay, so let's now create just a directory. I'm gonna call it CMS. By the way, we will refactor. We spoke about that last time. Okay, Now let's just create a CMS.go. And here we're just gonna ideate about how things might look like. And I will zoom in. We wanted to create a document and specify what a document is. So let me... One second. I gotta make sure you guys can see this. Scroll zoom, I think. Guys, my computer is like dying right now. Wonderful. Let me see if this is visible enough. Yeah, that's good. Even a bit more. Here you go. Why not? Okay, so we have a type. This type, we call it a document. And it's a struct. Great. Now what? What does a document consist of, right? And here I wanted to say, what happens if we have a document that consists of segments and we just put them as that massive array, and that will just create like that nested structure? Well, that's not the approach I'm going for. Otherwise, I don't think this stream would be interesting at all. But let's run with it anyways and see what happens. So if we have a type here, and this type is called a segment, and it's also a struct, and or is it? But anyways, we just have a segment right now, and you go here and you say my document has a title, which is a string. My document also have a bunch of segments, which is a list of segments. Of course, it should have an ID, which will be like uid.new. Well, it's actually just going to be a string, essentially, and you will get it from the UID. Digressing. Okay, so what happens now, right? Imagine now that you have this segment and it's getting really big. How can you also guarantee that you update inside the segment quickly? So if I have a document here in Notion, I can just simply go and from this H1 put an H2, right? And I just swap them. This operation, if we do it with this kind of like style of coding right now, or with this data structure to be a bit correct, it's fucked. You have to go through the array, you have to find out which segment are you trying to change, and you have to replace it or change it. Also, what happens if I go like in the middle and I add a block of like another H1 again, right? What happens in our solution? We have to think about these challenges, and this is where like data structures actually do come into play. I always hated the coding interviews. Like, I dread them from the bottom of my heart, because it's kind of like pressure with an interviewer and stuff. The Prime Man actually did change my opinion about it, and the way he described it is like, if you know the handshake of getting into the job, why don't you just like learn it? It's a great argument. I think he's right. But the main point is, it's best to learn data structures in practicality. So you have a challenge, you see why this is happening, and this is how you learn about it. In my opinion, this is the best approach. For regarding the coding interview stuff, I really think like take-home exercises is great, as long as of course it's something reasonable. You don't want to waste the candidate time, I've put a lot of hours into interviews that like ended up in like nothing, and they didn't even like provide feedback, which is terrible. It's a complete waste of time. And some coding interviews was extremely exciting. So yeah, back to the point. Now, what we know about an array is to do a search, you'll have to do an O of n, right? Which means that you'll have to go through every element in the array and ask it, are you the segment I'm looking for? Are you the segment I'm looking for? Are you the segment I'm looking for? And then once you find it, you can operate on it. Now think about an insertion. What does an insertion do? Well, an insertion you go like, are you the one I'm looking for? Are you the one I'm looking for? Are you the one I'm looking for? Yes? Okay. And then you want to shift everything else. So you say, start from the end, shift by one, move, 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 move. Terrible, right? And if we want to visualize what that looks like, we can simply do that with a bunch of rectangles. Let's say here's my slice of segments. A slice of segment. And here we have seg1, seg2, three, and I want to insert seg4. In seg4 here, let's just put it in orange. And now I'm trying to insert it between seg1 and seg2. So then what happens, right? It will go here, figure out first where to insert it. Let me just use a regular arrow actually. Or you know what? Problem solved. Okay. Guys, I love Figma regardless. Okay, so we have like segment 1, and then it says, are you segment 1? It says yes. Well, okay, I want to put something after you. So now what are we gonna do? Well, we need to extend the slice, or like in other words, we need to shift these to the right and then put the segment in between, because I cannot just go and insert it here. In order to do that, I have to shift first, which means that I will probably create a new slice of similar in length. So actually let me create a bigger rectangle just to like show how it's actually wrapped. Bam, 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 bam. So that was my current, my ignore this pointer for now. So this is my current slice, right? I have to go and say, well, actually, I'm adding one more, so please account an extra space. So I've already created more space. Okay. So, slices do that under the hood for you, and they have like specific rules for how they grow. I think they double until they reach a certain amount, and then they start like increasing a bit more slower. But regardless, this is really what's happening one way or another, right? Something has to give. So that structure has to get bigger. So it will say, okay, you know what? Let's move this from here. And now let's start at the end of this new slice. Let's start at the end of this new slice. And we just move it. So move this. This goes backwards. This moves backwards. Move this. Now, this is done. You go here. You add the new segment. You go here. Well, we said this is already done. And now you're done. So this is one way. The other way, which is still very similar to this, really. It's like if you have all these three, right? And you say, hey, I will start at the end. Start at the end here as well. And copy them over. So copy. Move backwards. Whoa. Move backwards. This is like giving me like lead code vibes. Not what we're doing, but I need you to get this because it's really cool. Okay, then you move backwards. You say, hey, this is the spot where I want to do the new insertion. So you insert your new item. Then this just moves backwards, and then the first one goes, and both of them are done. And here you go. But as you can imagine, when you're doing like document editing, you keep moving stuff up and down all the time. That could get too heavy of an operation, especially if you're actually storing the real segments. So these are big objects, and now you're like copying them around all over the place, shifting them, deleting items. We delete tons of content. Also imagine now that with every keystroke of that paragraph, you have to find the segment and go inside the segment and change it. So now let's actually say that this is a paragraph. And let's create this structure into our Notion pad right here. So here you go. We have a header. My first header. I have paragraph. Saying something. And then I have my H2, which will be my subheading, saying another thing. And I have my H3. Or actually, let's have this another subheading. Another subheading. Saying a third thing. And I might look at that and I'm already editing some stuff, right? So now I had to go, if what we have here in Figma right here is the implementation happening here, when I edited the subheading, I had to go through the document, go through each segment, these are all different segments, and try to change it, right? And you might be wondering, why did I say these are segments actually? Why isn't this just like a block of text? Because if that text is represented differently, it means it has different properties. And if you can do different things, for example, like here you can add like tagging someone, right? So you can say at and you can tag a person. And if you can tag a person, this means that you're adding behavior to these blocks. And these blocks are not just like regular text, right? They have behavior. So that's why I do think they're implemented as segments, or as they call them, blocks. So if I edit this right now, like this word paragraph, and I go to our implementation, what happened here is that it had to find where the paragraph segment is, and then it had to go and add the updated content to it. That's a costly operation. Okay, how can we fix this? Well, you might say, rather than storing it into just an array of segments, why don't we have a map of segments? Okay, so now what? So now we're gonna have a map with an ID and a segment, and that ID would be a string. And that's kind of like one way of doing it. Okay, let's have a look at this implementation now. So this is a bit different. So now what you actually have is this. Wait, that's not it yet. Okay, so this is what you have now. You have a bunch of IDs. So I have ID 1, ID 2, 3 and 4. You have segment. Okay, so that's an implementation. Let's look into what this solves and what it doesn't solve. So this solves like whenever you're editing, you know exactly where you're gonna go. So if I'm editing a paragraph here, like fixing this typo, I know that this is on my IDs 2, and I go fix it. So I saved the search operation, and I'm only doing the regular update operation inside the segment. So we can consider this like instant. Okay. Do you see any problems with that? What about ordering? How do you maintain an order here? Right? A map doesn't really have an order. Depending on your programming language, it might. But it's not a good idea to depend on the consistency of the map for ordering. So I could have them reshuffled. They would point to the correct object, but now when I get them back, I have ID 1. Let's even shuffle these just for demonstration. So each of them is still pointing to the proper object, but when I get them back, I might get them as a list of you work at 1, you might get 1, 3, 4, and 2, and this is not the order that you put them in, which is now your document wouldn't be in the proper order you want it. Well, that's fucked. If I wrote a book, or even if I wrote a personal note and I'm taking some time to organize things and shuffle them around that I'm excited about, and then you go and you just shuffle it depending on your map ordering algorithm, well, are you like, honestly, this is messed up. Okay, so another solution would be, let's have this map, but let's also have another slice that maintains the order. So we can have like segments orders, and that segment order could be like something like, hey, 1, 2, 3, 4, and 5. Or actually, let's stick to the same example, right? So I wanted ID 1, ID 4, followed by ID 2 on ID 3. That's the order that I wanted. And now, whenever I'm retrieving a document, what should I do? I just get the IDs from here, then I get them back. Yes, that solves the problem. Let's take a jab at this approach, and then let's look at the even better thing. So I have my segments here. This is a map of segments, and now I also need to order, or sorry, segments order, which is just going to be a slice of strings. Okay, now what? Now let's say I want to get all the segments. So for like the document, get all segments, and it would return a slice of segment, for example. Then I can go say for each Well, I do actually need the key, so seg ID. For each seg ID range segment order. What do I need to do? Well, we need results first, right? So let's say all segments, which is just going to be a slice of segment, and let's just initialize it like that. And then you say from the map, you need the segment, which is just going to be d.segments.segId, and that should return you a segment. And you say all segment equal append. Okay, and then of course you return all segments, and that approach works for every time you want to get all the segments in order. Technically, this is a great solution. Well, can we really do better? So I've been thinking about this thing, and it would really help us in like the next stream. But what happens if we... That's lagging. Give me a sec. Okay. So what happens if this becomes a well, I don't want to spoil it. There you go. So what happens if this is your document and now you have the little seg 1, seg 2, seg 3, and segment 4, and actually we want them in the order of like seg 1, 4, 2, and 3, right? Why we want them in segment 1, 4, 2, and 3? Because initially we created segment 1, 2, and 3, and then we wanted to create a segment 4, and then we shuffled segment 4 to the middle. Great. Okay. So now I have my document. What? Now we have my document. I have segment 1, 4, 2, and 3. Why isn't it not a tree? I need to call my like internet company. This is getting a lot of like lagging, I think. I'm so sorry, guys. I promise I will work on getting fixed as soon as possible. So what happens if document is just a tree now? Well, let's think of the implication of what that tree imposes. Just for consistency, let's do that. And I'm not saying a binary tree, because you want all these segments, right? And remember, these segments, if you leave a comment, oh, sorry, I have a comment right here. Yeah, so I'm trying to build a realistic Notion clone. You know, I don't work at Notion. I'm not associated with them by any means. I just think it's a very interesting challenge. And yeah, trying to think of like what it takes to build a system like Notion that is efficient, and see how this like model go end to end. Now we're just like in the whiteboard phase, and later on we will go into like more details of like as I mentioned in the beginning of the stream, things like optimistic concurrency. So what happens if you're editing the same document to multiple devices, how you can handle that, how you can handle like updating things really quickly in a document. From my knowledge, I know that like they use, I think, Postgres for their database. It's like a SQL-based database. We're actually doing a NoSQL. I'm not gonna spoil which one. You can take a guess, but it's gonna get really interesting over the past next week to solve this problem alone. So yeah. Okay, to continue. So what happens if we have a document with multiple segments as a tree structure? Well, you might be wondering, well, if I have a tree structure, how can I handle the ordering, and how can I handle the quick updates? Okay, so now if I want to update something, I would have to do the same thing that like we kind of did with an array, right? I would have to go here and add an extra link and push these to the side, right? Because a tree that like if it's not like binary tree, let's say you want to implement a tree with as many nodes as you want and as much nesting as you want, then really like you have your node and your node has like an array and that array also points to other nodes, but you're still dealing a bit with an array. You get efficiency in searching because like you can narrow things a bit down, but you're still dealing with an array. Okay, so that's if you implement the tree with an array, but you can also implement it with a map, right? Let's think about this. So if I have a document and that document now have a map, and that map includes like where these are, then we're back into this solution again, and we don't have a way of doing ordering. And then you go back into that segment order principle, unless you find a way that you can go through the tree consistently from left to right, where it always means that this is the exact sorting order, right? But then you can't guarantee that with a regular map, and you still need like a segment order. So I think it would be best for us to go with that approach. So where like you have your map and you have kind of like your segment order, and that kind of like acts like an index for where you can find these things. The tree would be an ideal solution if we're able to get rid of like the array problem in it, right? So if I have something like this, so if I have a type doc tree, and it will be a struct that takes a node. I'll just have it exposed as a pointer to a segment, right? And then you have your segment can also reference other segments, but now that becomes a linked list. So realistically speaking, you'll probably have to end up with something like this. So your node so like nodes, which is going to be like a list of nodes, actually, sorry, brain fart. Let's do this. So you have a type segment node, which is going to be a struct, and that struct simply points to another node. right? And this becomes your segment. You can create your segment tree from these, right? Because if I have a segment node here, so segment node, and it have a bunch of other segment nodes, so seg1, seg4, seg2, and seg3. So these are my segments, and now I can have seg1 pointing to like nested segments, right? So I can say like seg1 sub 1 and like seg1 sub 2. That's like having your first segment having multiple nested properties. The best example for that, if now let's say here's my first segment and I do like what is it called? Yeah, the toggle heading, right? So this is segment 1, and if I open it, I can nest down, and it could be like segment 1.1, segment 1.2. So these are the children of the segment, right? And this is kind of like what we're modeling here. And now if I want to add to the segment node, I will have to go through the segment node, find which one I want to update, and do the shifting that we did. So we might sacrifice shifting for like not having to do the map slice kind of thing. So for example, I'm actually not interested in storing the true segment, right? I'm only interested into having this tree to give me as minimal information about my segments, and I should have another mechanism of finding them. And essentially what you end up implementing is that you're implementing the segment order. Because if we go back, right, I'm not sure if you all noticed that, but if I'm changing the order, and order does matter, then my segment order becomes like a bottleneck of like swapping, right? So if I have like 1,000 segments, okay, and there are books that are 1,000 page long and even more, so can you imagine how many segments there is, right? So if you have all of these things and now you're just wanting to reorder one, you have to reorder everything. So that could be very, very costly. But realistically speaking, we're only interested in the orders of the IDs, and we're not really interested into retrieving the segment from the document, right? We can actually just like store the IDs, and if you have like in your database or whatever external storage, or even an M memory, and you say, hey, give me segment with that ID, and it goes like, oh, here you go, right? So looks like we might be stuck with an array. I wonder if wait, we have another question. Why are you using GoLang instead of Java or Python? Okay, that's a good question. I hate Java. Okay, I do think it's an ugly language, to be honest. You can do a lot with it, but I just like the JVM ecosystem is a bit annoying for me. I've worked with Kotlin and I actually loved it, so I could technically write it in Kotlin. Why I'm doing it with Go? Because it's a language that I've always been enjoying, and I do think you can get a lot out of it. It's not an incredibly it's a very expressive language, right? You can do a lot of like elegant stuff you can do like in Kotlin, for example, but it's very expressive, and it kind of forces you into becoming like good into thinking about the problems. An example of that is like error handling in Go. A lot of people find it annoying because you typically like return the error and you have to deal with it. But realistically speaking, if you don't, then you're setting up yourself for failure when an error happens. So that's something I like about Go. I don't know Python. I know like the bare minimum of the language, and I just never liked the ecosystem of it. It was a bit like annoying to get Python working in production systems and stuff. Um, and I honestly just wanted a strongly static type language. So yeah, hopefully that answers your question. But Python would be great for that too. Um, Even though I do think like a fully compiled language would be much better, so I would even favor like Kotlin or Go or Rust or even C++ if needed to that. All right. So we need to look up if there is a way we can have the order in an efficient way, right? And what about, again, going back to a tree, but rather than this is a tree of segment, it's a tree of ID, and rather than having it like an unbounded tree, what happens if you do a binary tree, right? So document, let's say I inserted segment 1, and I'm gonna insert it before the shuffle, right? And then we're gonna shuffle it afterwards. So here's seg 1. Seg 2. And now you have, let's say, seg 3. But now you want to change that into here. And now I inserted seg 4. Right, but let's say it's here. And now I want to shuffle. So we're doing like a breadth first, right? Like if I want to retrieve these in order, I would go like left, so seg 1, right, seg 2, then I go like the layer down, which gets seg 3, then get seg 4. So now if I want to shuffle this, I want to have seg 1, 4, 2, and 3. So I simply remove this link, right? We go from the start, and I want to change it with the second one. So I know it's like, it will always end up like either like ended to the left or ended to the right after these number of iterations. And I want to move it from like position 4 to position 2. So all what I need to do is like, okay, document, left, right. Okay, this is found the location, point to this, and now swap the link to 2. And now if I'm retrieving with the same sequence that we're doing, I retrieve seg 1, seg 4, seg 3, seg 2, right? And if I add seg 5, it goes here, left, right, then one level deeper, left, then right. And you can control your order. Well, this is seg 5. You can control your order of traversal the way you need it to. right? And this way you kind of like solve few things. So now your insertion is not taking that like what we call the amortized time, because like you're growing and shifting things around. Now you're really shifting, like changing links. So most of your operation is cost is like where to do that. And if you know the order, because let's say like from the front end you have 1, 2, 3, 4, 5, and 6, and you move it around. So you say, hey, I want to move 6 to become 2 now. So you already have this data. It's very minimal. I'm not sure if this would be classified as like log n, because you're not really like halving. You're still like kind of going a bit sequential. But you save the amortized time and you end up using a tree. So let's think now. I just kind of like, I want to get our conceptual model of the data structure that we're going to use in our head, right? And then we actually go and implement it. And when you implement it, most likely your data structure will be so much simplified because you're using like a database or something. But you need to get this right, because if you don't get this right, then you're modeling your data based on your database rather than like based on your model. And this is, I haven't even like touched like DDD or all the amazing stuff. Yeah, I might have something for you like regarding the DDD with one of my friends. He's running like his DDD course. It's actually pretty amazing. I highly recommend it, but I do have to work with him first in order to like get it up to you guys. So back to this tree. Can we solve it in like a depth first and still like maintain the order? Well, let's try. Never hurts to try. Okay, so I have my segment. Now I'm also gonna like insert left to right. So I inserted this segment 1. Now I have my segment 2. Again, we're doing like the regular insertion, then we'll shuffle, because we're assuming that we haven't had segment 4 and 5 yet. And now, so this is left and right, then segment 1 we can go left and right. So here's seg 3, which is left, and I have segment 4. Okay, so now I have this like structure, right? So I just fill left to right, deep first rather than breadth first. So here I go and I say 1, 2, 3, 4. If I try to insert 5, which I will, it will go here. Let's just expand our tree a bit and have this as the left node. Great. Okay, so now I want to move this node, so segment 4, to segment 2. And we have the number, right? So like from this position to that position. So simply I would like go to 4, right? So here insert, left is full, right is full, but this is where I want to swap it. So I'll just change my links to that. So here's my segment 4, and now I would have to shuffle these. Bam. But you also need to rebalance, right? Because now it's not balanced. And now you kind of like still, let's try to get the order from this and see if we did the right thing or wrong, right? So I go into my document, get all the segments, I go left to right. So segment 1, segment 4. Well, if we're doing depth first, then I really should go segment 1, segment 3, segment 2, segment 4, segment 5, which means that we fucked up. So let's undo all the way to like we have the 2 and 4 and see how we want to fix it. Okay, so I have segment 4. I want it to become like my second node. Okay, so let's do depth first while maintaining the index. So here's my segment 1, left. Segment 1, does it have a left? Yes, so I'm in layer 2 right now, and this is all what I need to switch. So now this goes left, this goes right. So now if I'm getting my data, I get segment 1, segment 4, segment 3, segment 2, segment 5. But that's not the exact order that we wanted. So, and this means that when we did the insertion in the first place, we didn't do it properly. Okay, and let's fix it now. I want 1, and then 1 to the left of it should be 2 and 3. So let's just remove that. Because remember, we're doing like a depth first. Actually, we're messing up right here too. Because if you're doing depth first insertion, then you're really just having like a linked list, right? Because this is what you're gonna have. You're gonna go to 4. So you're just created a linked list and you're calling it a tree, right? Well, I guess I led you there. So this is not right, but this is just like a linked list, and this is not what you want, because again, like, we don't suffer from like shifting problems that the array have, right? But here you suffer from finding stuff. So if I want to search for a segment for any reason, I would have to go like sequentially until like I find the node I'm interested in, and then I can operate on it. So for example, if I said, excuse me, if I said, I want to delete segment 4, right? I will have to go through my linked list. Okay, this is segment 1, segment 2, segment 3, segment 4. And then I found it. So this is an O of N operation, right? And what we're trying to do is like, are you able to find it in a smaller number, right? And we haven't really considered that you already have like your IDs for each of them. So I'm thinking right now, like, let's see how many solutions we have for that problem, right? So we have the linked list solution, we have like the tree solution, you have just like the array solution, and then we had like discussed why are we only storing IDs, and why are we not actually storing the segments, which in that case you had like 3 solutions as well. So how do we evaluate that? How do you evaluate which one to use, right? Well, think about your insertion. Are you mostly inserting and editing and like moving things around, well, if you're moving things around, then array is definitely, well, should be excluded. Okay, so if array is excluded, what can maintain order? Well, linked list, you do maintain the order, and it's the insertion, like your time. If you're inserting, if you're appending, that's you can call it an instant operation, right? You know where your last node is, and you just append to it. And if you're deleting, you still have to like find the node to delete. So, okay, that's a bit costly because I have to do that search. And if I'm shuffling things around, then I need to find what am I shuffling and to where I'm shuffling it. And you still have to go through these whole things as well. In the tree one, you kind of had to do like go through all of them in the breadth first anyways, because if I'm switching like node 4, I had to count like, okay, left and right. I couldn't half it, which is the whole purpose of like typically when you use a tree, is that you want to like exclude literally like half of your options. So the tree didn't serve us here. The map didn't serve us here either, because you can't have an order. So honestly, in that case, I would say like the linked list might be the best option, right? So we can just like implement it as a linked list. That could technically do it. Okay guys, I am getting a bit tired, so next time let's write down what we're going to be working on. Next time we will actually implement the solution for the segments. That's number 1. Number 2, start modeling your domain. So here we'll discuss things like how are we gonna like model this. So we've talked about like documents and segments and got into the weeds of like the data structure that represents it. But then how are you gonna do like, what are your rules? Who is able to create a segment? What is a segment? Right now, also we've been thinking about segments conceptually. But in the next one, which is actually very, very interesting, how are you gonna model like a paragraph, a header, a list with bullets, and all of these things just as a segment? A peak, yeah, maybe you can use an interface, but then how are you gonna get the data back and operate on it with like, you'll need to do like custom serialization and a bunch of like super interesting stuff. As I said in the beginning of the stream, this is gonna be like few weeks worth of like streaming, because it is not simple. You've seen how much time we spent today on just like evaluating what would be the best approach, just to like into picking a data structure. Next time we will start also implementing the segments model. And lastly, I want to implement the document service. And this document service is like, hey, I want to create a document, add a segment to it, and all of that stuff. You'll see it working. I did some work on it, and it's pretty interesting. So yeah, stay tuned. Thank you so much for whoever joined, and I hope to see you guys again on the next stream. Hit me up if you have any questions. leave comments and let me know in the comments again if you want me to implement the nested structures so you can nest stuff, segments within segments. Because if you do that, that linked list approach would need to change. So keep me posted about what you want to see next time, and see you later. Peace out.